A beam is freely supported over a span of 6 meters. It carries a uniformly distributed load of 20 kN per meter over 1.5 meters from the left hand support and also from the center up to the right hand support. It has besides two point loads of 20 kN and 50 kN at 1.5 meter and 4.5 meter from the left hand support. Construct the shear force and bending moment diagrams. Draw the free body diagram from the given data. This is a freely supported beam of span 6 meters. It carries a uniformly distributed load 20 kN per meter over 1.5 meter from left hand support. Up to 1.5 meter there is a UDL 20 kN per meter, and also from the center up to right hand support. The same UDL is acting from center to right hand support. Overall span is 6 meter. Center is located at this point. This is 3 meter from left hand support and 3 meter from right hand support. This is also 20 kN per meter. Two point loads of 20 kN and 50 kN at 1.5 meter and 4.5 meter from the left hand support. 20 kN point load is acting at 1.5 meter from left hand support. This is 20 kN point load which is acting at a distance of 1.5 from left hand support. 50 kN is acting at a distance of 4.5 meter from left hand support. This is 4.5 meter. Name this support is A and it is B, C, D. So this point is E. At E, 50 kN point load is acting. At D, 20 kN is acting. From the figure, we know that two UDLs are acting and two point loads are acting. So all the loads are acting vertically downward side. See, this is RA, that is support reaction at A, and support reaction at B is RB. Apply the condition sigma V is equal to 0. This means algebraic sum of all the vertical forces must be equal to 0. In this beam, vertically downward forces are 20 kN point load, 50 kN point load, 20 kN per meter UDL load and 20 kN per meter UDL load. And vertically upward forces are reaction at A and reaction at B. This can be written as vertically upward forces is equal to vertically downward forces. Vertically upward forces are RA plus RB is equal to vertically downward forces are first one 20 kN point load, second one is 50 kN point load, and two UDLs are acting. First one is 20 kN per meter which is acting at a distance of 1.5 meter. So it can be converted into point load. 20 is the UDL intensity into distance is 1.5 meter. So that we are converting this UDL into point load. Plus another UDL is 20 kN which is acting for a distance of 3 meters. So 20 into 3 meters. RA plus RB is equal to 20 plus 50 plus 30 plus 60. RA plus RB is equal to 70, 100, 160. Now apply algebraic sum of moments about A is equal to 0. Sigma MA is equal to 0. Taking moments about A is equal to 0. First one is 20 kN. This is the clockwise force acting with respect to A. 20 into force into perpendicular distance. Force is 20 kN. Perpendicular distance is 1.5. Plus another point load 50. Perpendicular distance is from 50 kN to this support 4.5 meters. Plus UDL 20 kN. First we have to convert this UDL into point load 20 into 1.5. This is acting at a distance of 1.5 and perpendicular distance which is equal to 1.5 by 2. Here 20 into 1.5 is the force, 1.5 by 2 is the perpendicular distance, plus another UDL. UDL can be converted into point load. First 20 into 3 meter is the force into perpendicular distance from E to A. This is 1.5. This is 3 meter. 1.5 plus 3 meter. So we have taken the clockwise moments. There is an anti-clockwise moment RB into 6. RB is the vertically upward force which is making anti-clockwise moment with respect to A. RB is the vertical force into perpendicular distances from B to A. We have taken all the clockwise moments are positive. So anti-clockwise moment is negative. Minus RB into 6 is equal to 0. 6 RB is equal to 547.5. Therefore RB is equal to 91.25 kilonewton. Substitute this RB value in RA plus RB is equal to 160. RA plus RB is equal to 160. We know RB value. RA plus 91.25 is equal to 160. Therefore RA is equal to 160 minus 91.25. RA is equal to 68.75 kilonewton. Now calculate the shear forces. For a section XX on the beam, the right side vertically upward force is taken as negative value. The vertically downward force acting on the right side of the section is taken as positive value. Similarly, for the left side of a section XX, vertically downward force is taken as negative value, vertically upward force is taken as positive value. For this beam AB, calculate the shear forces from B to A. Consider a section at B. The vertically upward force RB is acting. Therefore, shear force at B is equal to SFB is equal to vertically upward force is taken as negative. So minus RB. Shear force at B is equal to minus 91.25 kilonewton. Now calculate the shear force at E. At this point E, we can take the shear force just to the right of E, shear force just to the left of E. First take the shear force just to right of E. Shear force just to right of E. SFE right side is equal to, draw this figure. This is RB 91.25. This is 50 kilonewton, 20 kilonewton per meter intensity. This is 1.5 meter. So now consider a section just to right of E. So the forces acting on this section right side is 20 kilonewton per meter and 91.25 kilonewton. So shear force just to right of E, SFE is equal to vertically upward force is taken as minus 91.2. Vertically downward force is 20 kilonewton per meter UDL, which is taken as positive, plus force is 20 kilonewton per meter into 1.5. Therefore shear force at E just to right side of section, shear force just to right of E is equal to minus 91.25 plus 30 minus 61.25 kilonewton. Now calculate the shear force just to left of E. Shear force at E left side. Consider section here XX. Just to left side of E, there are three forces are available here. 50 kilonewton vertically downward acting, 20 kilonewton per meter UDL vertically downward, and 91.25 vertically upward force. Therefore vertically upward force 91.25 is minus 91.25 plus vertically downward is positive plus 50. Vertically downward UDL, convert it into concentrated load 20 into distance 1.5. Therefore shear force at E just to left of E, shear force just to left of E is equal to minus 11.25 kilonewton. Now calculate the shear force just to right of C. Consider a section just to right of C. The forces acting are 50 kilonewton and 20 kilonewton per meter UDL, vertically downward, and vertically upward force is 91.25. Shear force just to right of C. SFC, right side, vertically downward force is taken as positive 50 plus convert the UDL into concentrated load 20 into 3 meter. Vertical upward force is taken as negative minus 91.25. Shear force at C, right side, 50 plus 60 minus 91.25 plus 18.75 kilonewton. Shear force just to left of C. So consider section here, there will be no change, so shear force will be remain same, 18.75 kilonewton. Now calculate the shear force at D. The shear force just to right of D. SFD, right side, consider a section here just to right of D. Right side of this section, the forces available are 50 vertically downward force plus, which is also plus, UDL is 20 and distance is 3 meters minus 91.25. Therefore shear force at D right side is equal to plus 18.75 kilonewton. Now calculate shear force just to left of D. Shear force just to left of D, that is SFD left side. Draw the section just to left of D. So 20 kilonewton force is also available now. Plus 20 plus 50 plus 20 into 3 upward is minus 91.25. Therefore SFD left side is equal to 38.75 kilonewton. Now consider the section at A. Only one force is acting, that is reaction at A. We know at the section or just to left of section, upward force is positive. Therefore shear force at A, SFA is equal to plus 68.75 kilonewton. Now calculate the bending moments. Bending moment at B. Say it is MB is equal to 0. So here RB is acting, the perpendicular distance is 0. So MB is equal to 0. Next bending moment at E. That is M suffix E, ME is equal to, at ME consider the right side portion, 20 kilonewton per meter UDL is acting, it is acting clockwise direction and RB is acting anti-clockwise direction. Therefore clockwise moment is taken as positive, clockwise moment is UDL. Convert the UDL into point load 20 into 1.5, perpendicular distance is 1.5 by 2. Anti-clockwise moment is taken as negative, RB into 1.5. We know RB is equal to 91.25. ME is equal to 20 into 1.5, 30 into 1.5 by 2 minus 91.25 into 1.5. Moment at E is equal to minus 114.375 kilonewton meter. Bending moment at C, MC. Take the right hand side part of the C. Here one point load is acting 50 kilonewton and 20 kilonewton per meter is acting. These two are acting clockwise and RB is acting in anti-clockwise direction. So take the clockwise moments positive and anti-clockwise moments negative. Plus 50 into 1.5 plus 20 into 3. UDL is 20 and its distance is 3 into half of 3, that is 3 by 2 minus RB is 91.25 into perpendicular distance is 3. Therefore moment at MC is equal to minus 108.75 kilonewton meter. Bending moment at D. MD, take the right hand side portion of D, 50 kilonewton, 20 kilonewton per meter are acting in clockwise direction, RB is acting in anti-clockwise direction. So 50 into perpendicular distance from E to D is 3 meters plus UDL 20 into its distance is 3, so it is converted as point load into perpendicular distance from E to D, that is 3 by 2 plus 1.5. After converting the UDL 20 kilonewton, 20 into 3, 60 kilonewton, perpendicular distance is, this is 1.5, this is 1.5, that is 3 by 2 plus 1.5 minus RB into 4.5. Therefore bending moment at D, MD is equal to minus 80.625 kilonewton meter. Now calculate the bending moment at A. Bending moment at A, it can be written as M suffix A. There is no moment acting at A. The vertically upward force RA is acting, but there is no perpendicular distance. That can be written as RA into 0, 0. Or otherwise you take all the forces to the right side of A so that you get the MA. Take the forces 20 kilonewton per meter UDL, another 20 kilonewton per UDL, 50 kilonewton, 20 kilonewton. These are acting clockwise direction, RB into perpendicular distance. This RB is acting in anti-clockwise direction. Write the clockwise moments first and take the sign as positive for clockwise moments. First concentrated load 20 into perpendicular distance from D to A is 1.5 plus UDL 20 kilonewton, convert the UDL into concentrated load, so we have to multiply it with 1.5, that is the distance of UDL. After converting, it will be changed as 20 into 1.5, 30. It will be converted as point load, that is 30 kilonewton, 20 into 1.5, and perpendicular distance is 1.5 by 2. This distance 1.5 by 2, 1.5 by 2 plus another point load 50 into perpendicular distance from E to A, that is 4.5 plus another UDL is acting for a distance of 3 meters. This is 3 meters. First convert the UDL into point load 20 into 3, that is 60. So after converting, we can write the UDL as a point load with 60 kilonewton and take the perpendicular distance of this force acting at a point to A. This is the perpendicular distance from here to here, C to E 3 by 2 plus from C to A 3 meter. Take the anti-clockwise moment and sign is minus RB 91.25 into perpendicular distance from B to A 6 meters. Therefore MA is equal to 30 plus 22.5 plus 225 plus 270 minus 547.5. Therefore MA is equal to 0. Draw the shear force and bending moment diagrams. First draw the shear force diagram. This is a shear force line. Shear force at B, the calculated value is 91.25, that is negative value. So write the value here, draw the line below the shear force line, that is 91.25 kilonewton, and shear force at E, right side of E is minus 61.25, right here 61.25. This is a straight line. Shear force just to left of E is minus 11.25. It comes here 11.25 kilonewton, and shear force just to right of C is 18.7. So C is, this is the C point. Shear force just to right of C is 18.75. 18.75 kilonewton. Join these 2 points. Shear force just to left of C is also 18.75. Shear force just to right of D is 18.75. This is D point. Shear force remains same at D. This is also 18.75. Shear force just to left of D is 38.75. 38.75. Draw the vertical line above 18.75. Next shear force at A is 68.75. It may be here 68.75. Join these two lines. So this is positive, this is negative. This is shear force diagram. We can write it as SFD. Observe the shear force diagram. Shear force just to left of E is minus 11.25. Shear force just to right of C is plus 18.75. In this portion from E to C, shear force is 0 at this particular point. Let's find the position of this point from A. Assume the distance is X. Shear force is 0 at this point. Write the shear force values with respect to this point. Take the left hand side portion of this point. Shear force at A is, it is reaction at A, which is 68.75 kilonewton. It is with respect to this point. This RA is acting vertically upward. So take it as plus 68.75, and there is a UDL 20 kilonewton per meter, which is acting for a distance of 1.5 meter, which is acting vertically downward. So it is taken as negative minus 20 into 1.5. There is another load, which is a point load acting vertically downward, minus 20. There is a UDL from this point to this point. This is UDL acting. We have to calculate the shear force from C to this particular point. So UDL intensity is 20 kilonewton per meter. From here to here the distance is 3 meters. This distance is x minus 3 meters. The UDL load 20 kilonewton per meter is acting vertically downward, and the value of this load is 20 into x minus 3. Why? Because we are converting this UDL into point load is equal to 0. Shear force is 0 at this point. We have written all the shear forces with respect to this point. Shear forces left to this point, 68.75 minus 30 minus 20 minus 20x plus 60 is equal to 0. 68.75 minus 50 plus 60 plus 10 minus 20x is equal to 0. 20x is equal to 78.75. Therefore x is equal to 3.94 meters. X value is 3.94 meters. Shear force will become 0 at a distance 3.94 from support A. Draw the bending moment diagram. Draw a bending moment line. Locate the points. This is A, this is D, this is C, this is E, this is B. Shear force diagram is completed. Now draw the bending moment diagram. Bending moment at B is 0. Bending moment at E is 114.375, which is negative value. So write the value below the line. This is minus 114.375. MC is equal to minus 108.75. This also comes below the line. Why? Because it has a negative value, minus 108.75, and MD is equal to minus 80.625. Negative value. Join these 2 points, and MA is also 0. This is bending moment diagram. We write it as BMD in shortcut.